Hello, I am Daniele Venzano. I am going to talk about our experience in using and contributing OpenStack for big data research. I am a researcher at Eurecom, a research institution in southern France. In Eurecom, there are several teams that focus on different areas of computer science. In my group, we work in particular on distributed systems and virtualized data-intensive applications, mainly Hadoop and Spark, but also we work on the whole stack from the top algorithms on MapReduce, then on the computer engines themselves, and on the lower level of our stack on OpenStack. This talk is going to be very short. Feel free to contact me later if you have any questions. Our main contribution to OpenStack has been the development of a Spark plugin for Sahara. Spark is an in-memory computer engine for MapReduce that is very performant for iterative algorithms. Recently, it was contributed as a full Apache project. Before our contribution in Sahara, it was only possible to have Hadoop clusters, but we use Spark, so we decided to develop some code so that we could have the same ease of use as Hadoop, also for Spark in OpenStack. The community, the Sahara community, was very interested in our work, and they helped us all along with the contribution. The code was merged in May, and since then we saw several external contributions highlighting the importance of our work. Right now we are working on some ideas on a better placement for virtual machines when a new Sahara cluster is created. We feel that data-intensive applications have well-known I/O patterns that can be exploited to have less interference and better performance overall. A few words on contributing to OpenStack. Contributing to OpenStack for us was a bit different than with the other open source projects. We develop a lot of code, and we always try to give back to the community as much as possible. With OpenStack, we saw that contributing code developing the code is actually very fast, because writing code in Python is easy and fast. Instead, actually getting the code to be contributed took a very long time, mostly because there were many iterations over small issues that could have been prevented at the source if we could have access to some better documentation about the process itself. In particular, I am speaking about some documentation about guidelines that could be shared between the developers and the reviewers that could help weed out some issues beforehand. Also, in OpenStack, there are a lot of tests that are run automatically, but it is always not always obvious on how they can be run locally on a local OpenStack instance. Another issue we had was, and we are currently having it, is that OpenStack is evolving at a very fast pace. And it is very difficult for a small team that is not focusing on OpenStack alone to follow on all different new projects and features that are contributed continually. From the operations point of view, we maintain our own small OpenStack cloud for a private use. We use it for developing OpenStack itself, but also we use it for Hadoop jobs and for teaching activities and laboratories. We started a couple of years ago with Folsom, And then we kept upgrading all the way to high SOUS with each new release that was available. Along the way, we saw the technical debt growing and growing. And I highlighted a few points on the slides that were a cause of some pain for us during this path. In particular, the upgrade to high SOUS was very painful, and we found bugs almost everywhere, in the documentation, in the packages, and in the software itself. As I heard during this summit already, we are not alone in having problems with Neutron and Ceilometer. With Neutron, we feel, for us it works, but there are many ways it can be configured, and we are not sure we are using the best way for our use case. For Ceilometer, we ended up cooking our own solution with Elasticsearch. Concluding, this presentation covered only our OpenStack contribution, but we also work on a bigger project called Bigfoot that is funded by the European Union. This project covers other topics like machine learning at a high level, doing data analysis for smart meters and spam datasets. We also modified Hadoop, implementing a new job scheduler. And finally, we work on data stores for large amounts of data. Thank you. Feel free to contact us using these links.